So the error bound states that the error, or the absolute value of an error, which can also be written as the remainder of n with respect to x, absolute value is less than k times x minus c to the power of n plus 1 over n plus 1 factorial, where k is the maximum value of the next derivative evaluated on your interval, which is a mouthful, but actually a lot easier to calculate once you get the hang of it. And so in our particular case, our c is 0. So let's just rewrite everything. So we have k, x is 1/8, c is 0, n plus 1. Since we expanded to the second order Maclaurin, we would have the second order plus 1, so we would use the third order to 3 factorial, divided by 3 factorial. And k is equal to, k is greater than f to the n plus 1 of x, where x belongs to the interval 0 to 1/8. So I picked the, or not, I guess x is not a great choice because we used x already. But so I picked an interval of 0 to 1/8 because I centered my polynomial at 0 and now I'm evaluating at 1/8. So the interval of my interest is 0 to 1/8. The f to the n plus 1 is actually f to the third derivative of t, where t belongs to 0 to 1/8. And the third derivative of our function is actually also e to the t, e to the x, and then we substitute in the t, so e to the t. And the largest value of that is actually e to the power of 1/8, because e to the power of t is an increasing function. But that would be kind of silly if we had to evaluate e to the power of 1/8, because e to the power of 1/8 is literally what we were looking for. So if in our error we had to calculate what we were just looking for, this is rather silly. So instead of saying that k has to be greater than 1/8, we can alternatively just say that k is greater than 3, because we know that on the interval of 1 to 1/8, e to the power of any of these numbers will never exceed 3, because e to the power of 1 is 2.7 something, and so none of that ever exceeds 3. So then we can just say that, well, this is equal to 3 over 3 factorial, which is equal to 1 over 8 cubed times 2. So our error is less than 1 over 8 cubed to the power of 1 over 8 cubed times 2. So this is our error, which is quite a small number. So I know for sure that this series, or this approximation, is accurate to at least 2 decimal places.